Good morning, friends. Today we'll start with whatever I have explained in the last class regarding the D.L. principle. So, the same concept we are going to use to solve the static problems based on where the criteria is acceleration. By knowing the force or by knowing the acceleration, you will be able to determine either the force or the accelerations. So, as we know that the D. L. principle is the system of, you can state that the system of forces acting on a body is in dynamic equilibrium with the inertia force of the body. So that when the body is under motion, it is subject to some resultant force. Because of that, that body is moving, and the inertia force is opposing. This will balance. So that's why I call it as dynamic equilibrium. Now, before I go into the solving the problem, I want to explain you regarding some linear motion of a body, uniform linear motion, motion of with uniform acceleration. That is, these are the equations sometimes we are required to use while solving these problems or study problems on D.L. principle or work energy equations or impulse momentum. So before that's why I just want three formulas are there which we may have to frequently use while solving. So we should know that how these equations have arrived. Now when a body is under uniform motion, so if it accelerates and it increases its velocity from u initial velocity to the final velocity v. So during that it accelerates from u to v. That is the difference of speed will change. So you want to know what is that difference of velocity divided by the time taken to achieve that. That is called the acceleration. So that is the equation 1. A is the acceleration is equal to v is the final velocity and u is the initial velocity by t. So that gives the acceleration, and I can rewrite that equation as shown in the equation number 2, that is v equal to u plus at. It is a standard equation. Similarly, for displacements, if you want to calculate if the particular body moves from one place to the from place A to the place B, then how much distance it has traveled. So that can also be worked out by this equation number 3, that is S is the displacement is equal to u plus v. So during the distance traveling, it has achieved its velocity from u to the v. So I can take the average velocity u plus v divided by 2. That gives the average velocity multiplied by the time taken to reach that spot. That gives the equation of this one, that is S is equal to that gives the displacement S, equation number 3, S is equal to u plus v upon 2 into t. So by substituting 2 in 1, equation number 1, that instead of t you substitute there, you will get 2 is uv is equal to u plus at. So instead of v, you substitute u plus at in equation number 3. That equation will be converted into ut plus half at square. This is the next standard equation. Now we will come to the next stage, that from equation 1 you bring the t at the left side and a at the right side. That equation becomes t is equal to v minus u from divided by a. That one I will substitute in equation number v is s is equal to u plus v by 2 into t. Instead of t, I will substitute that value, so that I will get an equation v square minus u square equal to 2s. So here the initial and final velocities are related to the acceleration as well as displacement. So these are the three standard equations which we may have to use in solving the static problems. That's why just I explain you. Now we will come to directly to the first simple problem, so that we want to understand what is the concept behind that, how we should apply it. So that's why I have taken a very simple problem. Here a force P is acting on a body at an angle of 30 degrees, and it achieves a velocity of 3 acceleration of 3 meters per second square. To achieve this acceleration, how much force P is required to be applied by V? So that is what we want to determine by using D'Alembert's principle. Now here is a free body diagram is shown here, so that this free body diagram will explain you that is what are the forces acting on the body and it is under dynamic equilibrium. Now you can see here weight of the body is acting downwards, and this there is a normal reaction acting in the upward directions. Now when the body is moving in the right directions, that time because of the external agency P is acting on that at an angle of 30 degree, the inertia force MA opposes the motion. So therefore the direction of the inertia force is opposite to the direction of the motion. That is what is shown here. So M is the mass, that will be weight we know at 1 kilonewton. So therefore 1 divided by G, acceleration to gravity, multiplied by the acceleration 3. So and there is a contact between the body and the surface. So therefore there is a frictional force acting, and the frictional force opposes the motion of the body. So that's why that frictional force F is shown opposite to the direction of the motion. Anyway, I will take one more. You are required to brush up your friction chapter. In the meantime, also I will give one session on that. It is a self-study topic in your subject syllabus, but anyway I will cover in one session for that also. Just you take the equation what I am giving now. So therefore these are the free body diagram of this one. Now simply you have to apply the dynamic equilibrium condition. That is, one is the sum of V is equal to 0 and second is the sum of H is equal to 0. By applying this dynamic equilibrium, we will be able to solve the unknown forces P. Now first we will come to the first step, that first you apply sum of V is equal to 0. So if you apply sum of all vertical forces should be 0. What are the vertical forces are acting? One is the 1 kilonewton acting downwards, it is minus. N is acting upwards, I will take it as plus. And the frictional force P is acting on that. It makes an angle of 30 degree. The vertical component will be acting in the downward directions. That is also taken as minus. So therefore minus P, N is upwards, 1 kilometer is downwards, and this P, this 1 kilometer is also acting downwards. So that is taken 1 minus 1 minus P sin 30 plus N is equal to 0. Now after solving this one, N is equal to 1 plus P upon 2, sin that is equal to P by 2. You will get, that is the normal reaction acting on that. And you know that mu is equal to coefficient of friction, where mu is equal to F upon N, where F is the friction force, N is the normal reaction. Just you take that equation now. But you want to determine F. F is equal to mu into N from this equation, right equation. Therefore F is equal to 0.251 plus P by 2. 0.25 is the coefficient of friction. Similarly, you apply sum of all horizontal forces to 0. What are the horizontal forces are acting? Frictional force and inertial force are acting opposite, and P cos 30 is acting towards the right. So that is positive. P cos 30 minus F minus MA 3 upon 9 is equal to 0. So substitute that one, and you will get one more equation, that is P cos 30 minus 0.25 1 plus P by 2 minus 3 upon 9. That is equation number 2. So by solving this and the from this equation, by equating this one, by solving this, there is only one unknown is P, and by solving this P equation, you will get the value of P, that is equal to 0.561 kilonewton. This is the first problem. Just you again go and brush it up